So in this video, we'll try to understand and work on the problem rearranging fruits, okay, which is a LeetCode hard problem. So let's take a look at the problem statements. So it says that we are given two baskets, B1 and B2. I'm going to write them as B1 and B2. So I'm just running example 1. B1 contains 4222 and these are the number of fruits that can be contained in these baskets. Okay, B2 contains 1412. So the goal of this problem is to make B1 and B2 look exactly same. Okay, how can we do that? So we are permitted the operation where we can pick any index I in B1, okay, and pick any index j in B2, and then we can swap the values of those two indices. Okay, and by doing that we want to make sure that in the end our baskets look exactly same. Okay, there is a cost associated with each swap operation, and then that cost is min of B1 of I and B2 of j. Okay, so this is the cost. So we have to, the question asks that whether we can do it, whether we can make the two baskets look same or not. That is the first question. If we cannot, then we have to return -1. If we can, then we have to return the min cost. Okay, so that's what the question says. Okay, so how to do it now? If we look closely, we can, so let's take a look at this example, 4222 and 1412. So 4 and 4 are present already, so we don't need to swap these. Okay, 2 and 2 are present, so this is also fine. Now there are two ones here in basket 2, and there are two 2s here. Okay, so if we swap 1 and 2, we are done, right? The content would be exactly same. So and the cost would be how much? Our cost would become min of 1 and 2, which would be 1, right? So similarly, so this is one operation. So in cost 1, we made both the baskets similar. Now take a look at the second example, so which is 2 3 4 1. This is B1 basket 1, and basket 2 is 3251 251. So again 1 and 1 are same, that is fine. 2 and 2 are same, that is also fine. 3 and 3 are same, that is also fine. But there is 4 value here in B1 and 5 here, so there is no way to do that. Okay, so here our answer would be -1. Okay, so if you look closely, like we can only achieve, like we can only make the basket similar if we have even number of quantities. Okay, so here what I mean is, here there is 1 4 and there is 1 5, which is odd. The difference is odd, right? There is 1 4 and there is 1 5. So this is there's no way to make B1 and B2 same, because to make them same we need to have even number of copies. Okay, if there are odd number of copies, then they cannot be distributed evenly, right? So so that is one condition, that we need even quantities. Okay, if any of the mismatched values in B1 or B2 are odd, then we cannot make the baskets look same. So in that case we would return -1. Otherwise we can make the baskets look same actually. Now we come to the second part of the question, which is min cost. How to find the min cost? Okay, so let's take an example. Let's see, we have 1 1 and then we have 10 10. Okay, and here we have let's say 100 100, and we have 2 and 2. Okay, so what would be the minimum cost? First let's try it out. So what we would do is we would swap 1 and 100. Okay, and so first notice that every quantity is even. 1 is 2 times here, 10 is 2 times here, 100 is twice, and 2 is twice. Okay, Now to make them same with minimum cost, what we have to do is, one approach that we can pick is like we can have the minimum, we can pick the minimum value from B1 and swap it with maximum value of B2. Okay, when we do that, so let's say we are swapping 1 and 100, the cost would be 1, right? So this is the cost of one swap, 100 goes there and 1 is here now. Okay, and what is another swap that we have to do? It's 2 and 10, right? So again, min of 2 and 10. Okay, so which is 2. So the total cost is 1 plus 2, which is 3. In total cost 3, we can do the we can make the baskets look same, right? So after the first swap, what happens after the first swap? This 100, this becomes 100, this becomes 1, and then after the second swap between 2 and 10, 10 comes here, 2 goes here. So now the content of basket B1 is 1, 2, 10 and 100, and basket B2 is again 1, 2, 10 and 100, which is same. Okay, so one approach we can so we saw that how we can make the basket look same in minimum cost is we can pick the minimum number, the lowest values of one basket and swap it with the larger values of the second basket. Okay, so that's why we picked 1, and we swapped it with 100, and then we picked 2, which was the second smallest value, and we swapped it with 10. Okay, so that is one approach, but also take a look at this scenario. So let's take another example and see if there is any other way in which we can achieve a minimum cost. So let's take this example. Basket B1 is 1, and then I say 5, 5, and then 100, 100, and then basket B2 is 1, and then we have, let's say, 10, 10, 200, 200. So first thing to notice is 1 and 1 is a match, so that is fine. All other mismatches are in even, right? So 5 is twice, 100 is twice, 10 is twice, and 200 is twice. So we can make the baskets B1 and B2 look same. Okay, how can we do that? So one of the approaches could be to swap 5 and 200, okay, and then plus the swap of 10 and 100. Okay, but what would be the cost in this case? 5 plus 10, which would be 15. Okay, but can we do better? Yes. So how? So we can use this one as a intermediate value to swap. Okay, what do I mean by that is, consider this. So what I would do is I would swap 5 with 1 and then 1 with 200. Okay, so what would be my basket look like after that? 200 and then 1 and then 5 and then 100 and 100. This is B1. B2 would be 5, okay, 10, 10, and then 1 and 200, right? So you see, this is exactly similar to swapping 5 and 200, but what is the cost if we are doing like this? So what we did is we swapped 5 and 1, and then we swap 201, right? And the cost is 1 plus 1, only 2, where previously like this operation costed me 5. So we did it in like much lesser cost, right? Again, now from this stage we have to swap 10 and 100, right? So if we simply swap 10 and 100, it would cost me 10, right? But let's say again we can use 1 as intermediate, right? So what we can do is, I would say I would swap 1 with 10, and then I would swap 1 and 100. Okay, so basically I'm going to swap these two, and then I'm basically going to swap these two. Okay, so what would be my basket content now? So B1 would become 200, 10, 5, 1, 100, and B2 would become 5, 1, 10, 100 and 200. So both of them are now same, as you can see. And the cost of doing it like this is again 1 plus 1 equals 2. So the total cost is 4, right? Whereas previously it costed us 15, right? So that's the logic. So to summarize, we just have to kind of what we have to do is we have to find the mismatches in both the baskets, and we have to see. So first thing we have to say is all the mismatches should be in pairs, like in even, right? If there is any mismatch value which has odd occurrings, then we cannot make baskets equal. That is one condition. Another condition is then we would see if we will pick the minimum value of both of these baskets, right? So here, for example, in this case, we picked 1 as intermediate swap. We have two options in swapping, right? First option is to pick the minimum and swap it with the maximum value of second basket, right? Pick the next minimum and swap it with the next maximum value of the another basket. But another option for us is to use a intermediate value, right? So as we saw in this example, we used 1, and we can use the minimum value of both of these baskets, which is same, as many number of times as possible, because so what we did is like we swap 1 with 10 and 1 with 100. So it basically makes no difference in the matched value, right? So that is it. Let's see the code. So this is the code to solve this problem, and it implements the same logic that we discussed. Okay, so here I'm creating a map, and then I am just storing the count. And then what I'm doing here is, if you see, like I am saying that I'm just negating all the counts. So if the value is present in B1, then it would be subtracted by 1. Otherwise, we would put -1 if it's a new value. Okay. And then this is just to hold the result. We are creating a new array list. We'll see why. And then we have a minimum. This mn will keep the minimum value of both of the baskets. Now what I'm doing is I'm just iterating over this map, and this is on line 15. This is the condition where I am just checking if there is any value in the map which has odd occurrings, right? If it is the case, then we simply return -1. Otherwise, this is where we are just keeping track of the minimum value, okay, of both of the baskets. Now here what we are doing is, so how many swaps we need to do? So suppose 2 occurs twice in one of the basket, so it needs to go once in the second basket, right? So if 2 is present with value 2 in first basket, after distribution, to make B1 and B2 look equal, it has to go into second. So one of the 2 should go into the second basket. So this is what we are doing here. We are like moving half of the values to this list, okay? And why we are moving it to the list? Like we need to swap with the minimum values, right? So that's why we have to pick we are storing it in a list, and then we would be sorting, okay? We would be sorting to see how, like we are just sorting the list, and then we are just iterating till half of the list, because each value would be swapped with corresponding value in the other half, which would make both the baskets equal, okay? And here again, like as I said, like we have two options when we are swapping. Either the cost would be like this value, the minimum value of swapping them directly, or it would be twice of the minimum value present in both the baskets, okay? So whatever is the minimum, we would pick that and we would add it to the result, and in the end, like that would return. So that is it. Like we can submit this and this would work. So let me know if you have any questions in the comments. Thanks for watching.